How many of these things are we going to do? Oh,
I don't know.
hey, morning. Peace. How y'all doing this morning? Yeah, we're back here in the bunker again. This one, I would have to say, we joke about this a lot, but a lot of this is a lot of scrambling for Jarrett and for Chris in the mornings, getting this stuff together. And Chris was on vacation last week. If anybody in this company deserved a week vacation, it was Chris Mullins. So he got to chill out for a week. So this is probably, wouldn't you say, probably the most slapped together? It's right there. It's a tie maybe for one of the first ones we did.
Good job building up in the audience.
Yeah, well, we're trying to get them ramped up.
Together.
Yeah, we're trying to get y'all all jacked up. So, but there's going to be a lot of good information because as we were just talking about it this morning, I learned some stuff. And so I know it's going to be great for you as far as learning to do your job out there a little bit better. And so we call this more advanced because we're going to use the machines in ways we don't normally every day use them. So that's what we're going to do today. So we're going to show you some different levels of troubleshooting you can use with them and take the machine and use it for a little bit, some specific problems you see out in the field. Some of them have been directly sent in to us by customers that we're talking about today. So so we know you guys see it in the field and we're going to give you different ways to cope with it. So we got the, this is series 10 of the COVID series. So today we're doing the advanced troubleshooting on the 3 and Thursday we'll do advanced troubleshooting with the 7. And you know the 7 has more features on it, so you can get a little bit wilder with some of the different methods that you use to find these problems out there in the field. So we'll be talking about that Thursday. So we're going to start right into this right after I say a quick prayer. All right? Father, thank you so much for this day. Thank you for this time that we can spend not just with customers, but with friends, Father. And we're talking about doing our job safer and better out there. And thank you for this time to do it. Thank you for the means of doing it, this technology and things that we can do this. And Father, we thank you so much for the Powermetrix family out there. Just heard great reports on one of our brothers out there that's through the COVID now, and he's back at work, and love hearing those stories. And we were lucky enough to pray with him. And Father, we just, anybody out there that's either suffering through this or has family members suffering through it, we just reach out to them, Father, and just watch over them, get them through it, and just give them that comfort that it's nothing the world can show them, Father. You give them comfort beyond all understanding. So, Father, thank you so much for the time today again. Thank you so much for the ability to just even pray to you this morning, because I know what it took to do that. It took your Son on the cross. So all of these things I say, according to the will of the one who paid it all, my brother, Jesus Christ. Amen. Let's roll. Okay. So we're going to get into some stuff that you haven't normally seen on there before, and we've talked before about the where we measure for the burden. You can measure CT or PT burden. Okay, you can actually measure the burden. We've talked before about, you know, for the longest time when you talked about burden and testing, it was always burden added. You would just add the burden, add more resistance, is all burden is. So you're adding more resistance to the circuit. And then as you start putting more burden on the CTs, it's one of the two enemies of them, right? You got heat and burden. And so as you start adding that burden, you want to see where does it fail. And when I first started, that's what they would tell me. You know, we're going to add, you know, 0.1, 0.3, 0.5, 1, 2, 4. We can only go all the way up to 4 ohms. They even have the little momentary switches. You just hit them with 4 ohms. And what they're looking for is failure of the CT, simulated failure of the CT. So where am I? Am I okay? Could it handle some more resistance or looseness, or is it right on the ragged edge? And maybe too small a wire. We talked about that before. But then we get into the burden measurement. That's something unique to the 3 series. So if you can measure the burden, it's that added tool. We're going to give you a good demonstration of that here this morning. Of you go and do your test, but you notice a little something out, and you can use the ability of the 3 series with that burden measurement to pinpoint the problem. We've talked about it before, but now we got a little simulation of it we're going to perform on.
All right, let's do it.
Okay, so we're just going to run a standard test. I'll tell you what we'll do. We'll run just a CT customer load test right here.
Okay, my gloves.
Everything's closed in, my current's closed in, my voltages look good. I'm using flex rings here.
Yep, so we got our flexes in. We're single wrapping them.
Yes, sir.
All right, Ray's got them in single wrapped, so everything looks okay. So we're going to go ahead and try testing those CTs. Didn't double wrap anything.
Yes, sir.
Always remember, watch for that double wrap box. You'll do it once, and then you won't do it again, but you'll forget to check the double wrap, and you'll notice, why is it saying 400s instead of 200s on my CTs?
I've done that before.
Oh, yeah. So we will go next. It looks like it's connected okay.
Waiting for test.
So here's where in the field, we're running a test. We're just testing our CTs now. And this is part of, you know, these and this. So if you notice something, you have 3 phases there. They should all be pretty consistent. You know, you should all have a pretty good balanced load. You know of your particular sites where you got particular problems because of the customer. But most of the time, they should be fairly balanced, my 3 phases. So you can see here, I got a pass on A phase. I got a pass on B phase. You can see it's pretty consistent there, right? Now I got a pass on C phase right here. And notice on C phase, my secondary current seems to be a little bit low. And I wonder why I've got a little bit lower on C phase than I do A and B phase. Here's where you might say, well, here's where I can use that added tool of the burden measurement. Let me actually take a look, because why isn't it consistent with the other ones? It seems to be a little bit low there. So why don't we run a burden measurement test on it, and that way maybe we can pinpoint and see where the problem is, okay?
Correct.
So that's what we're going to do now.
Balanced load, too,
That's right. That's exactly right. So I'm going to go previous. So now, what Ray's doing right here, remember, if you have the capability of doing it, which we do here, and you would if you had the CTs in the pad mount, or you had CT can right there beside the meter, you can make the connections, right, directly, right there on my secondary terminals on the CT, and Ray's just going from top down. It's A, B, C, so he's going red, yellow, blue, and he's getting on the, he's getting right there on that, my dot side with the red, yellow, blue, and then since my returns are tied together, he's just gotten there on one of the returns there with the white. So now we're going to measure, when you do that, you're literally, think about this, you're measuring the current all the way to the meter and back. Okay, all the way to that meter and back. Okay, so we're doing a direct connect here.
All right.
All right, so let's go ahead and run
Good.
this. Wrong button. I need to revert attention. We're just nailing these cameras this morning.
Yeah, I just hit that.
I know, I just bumped this one.
Jared's gonna
Yeah,
do this.
Jared.
Okay.
I can feel his eyes burning in the back of my head. All right, so we're cool. All right.
Yeah.
Now remember, go ahead. Ray.
No, I was going to ask you, so if that's all 0 here, so I'm not calculating my length. So can you explain a little bit of what you were saying? Because
That's a good question. So you got 2 options on doing a CT burden measurement. Okay. Option number 1 is what Ray's done right over here, where he is direct connected to it. And if you direct connect to it, now it's measuring that, it's actually measuring through the wire. I don't have to enter a length in there, so I'll leave those as 0s. If I did have overhead CTs, I would make my connections. Now, I just talked with a fellow this morning. As a matter of fact, you got a hard hat on from those fellows. So I was talking to a guy about this just this morning, as a matter of fact. And we were talking about when I measure it and I have overhead CTs, I'm going to connect up at the test switch. So I'm going to get over on, instead of where he's got it connected on the dot side of my CTs, I'll get over here on the shunts on my test switch with my red, yellow, and blue. And then I'll just go into my returns with my white and connect there. So what it's measuring is it's measuring everything in that can right there, any problems in the can. And if you look at how many terminations there are, how many connections and terminations right there, I mean, there's the probability and the chances are pretty good that I could have something loose in there. But let's say that when I test that, all I'm going to do is, when I test that, I'm going to direct measure in the can, I'm going to enter in a length. So right here I'd enter in a length, and it would just give me, we know for the different size of wire, we know the ohms per foot, and it just calculates it. We talked about this before, that if you have one of them directly measurement, if I leave it 0s, it will direct measure the burden in each phase, and I'll have an exact measurement. If I have to put a length in here because they're overheads, I will have an exact measurement in the can, but then it will calculate per foot the 30 feet there and back, so I put in 60 feet, and it'll give me that. Now, if it says everything passes, remember I had a funky measurement earlier, something a little off, like Ray's test earlier showed. I know I got a problem I'm trying to find. I've eliminated one of the areas. So if you think about it, all the connections down here at the bottom of the pole is one source where I could probably have a problem. Then up there at the connections at the CT. So you would go up there and you would look, and if the problem was the connections at the CT, you would find them. So one eliminates one of the two areas where you have most of the problems at the bottom of the pole. The other one shows you exactly where it is. And I've used the example before where I had one and there was a problem like that, and they hadn't peeled the wire back on the return into one of the CTs. Well, if they had been overhead, they weren't, so we actually looked at the numbers, and it showed 6 ohms on A phase, which I knew was way out, so did everybody, so we knew there was a problem, and we found the wire not peeled back on the return on the A phase CT. If it had been overhead, it would have looked okay, but my CT ratio test before that looked funky. So I would have said, well, it's not here, let me go up and look at the CT, and that's when you would have found the wire not peeled back.
Okay, I got you. So again, let me recap. So are you saying that I need to actually place my voltage leads on the polarity in the test switch?
Yes, in other words,
Okay.
I would get over here, you're exactly right, I would get on my shunt blades here and then just grab a return. So it goes shunt blade in and then back to the return.
Okay.
Yep, you're exactly right. So we'll go ahead and run this bad boy, and we're going to leave those zeros because Ray is directly connected to them. So A phase looks good. B, now C was the one we were curious about. Bam. So C has almost got twice as much, well, it does have twice as much resistance as the others. So I've got twice as much resistance on C phase. My CT's not failed, but I'm losing money every day because I've got more resistance for some reason on C phase. Now, Ray will show you right over here what we actually did to simulate this for you guys this morning.
Yeah, okay, so what I did was I grabbed some wire here and just went off the polarity side of the CT and added a length here, and then of course we ran the test before, you know, we done the show here, but we knew that it was going to fail as far as, if you can look, the voltage actually increased by almost half. You see that?
Mm-hmm.
So even though it says pass here, but there is a problem.
Yes, there is absolutely. And if we had run enough, obviously, it would have actually
Yeah, it would have
failed.
definitely failed.
Yeah, it would have
correct.
failed. But we want to show you where you're not a fail, but you're losing money every single day.
You're right
Okay?
on the edge.
You're right on that edge.
Yeah.
Cool. Now, on a PT, if we did the same thing, let's say we had it with PTs, and we wanted to do a PT burden measure. Okay? With a PT burden measure, we're comparing on this one. We're looking at primary versus the secondary, right? So in this case, we would need to somehow make the connections. So we're going to use these right here that Ray's going to show you right here.
Yeah. So what we will do is we're going to measure current on the voltage side. So what we would actually do is we would actually take our MN114s and we would actually clip it on to the voltage side, and that's where we want to take our measurement.
That's right. That's exactly right.
Everybody see that? So I'd actually clip on my voltage, and these are actually current, so that's what you're measuring on the voltage side.
And since
Right.
it's such a small amount of current,
Yeah.
that MM114 is the best because it's the lower range but more accurate for that lower
Yeah.
range probe.
The diameter is really small, so accuracy is really great on this.
Cool.
All right.
So you would do the same thing if you had an issue with your PTs. If you noticed when you did your PT ratio, one of them was out a little bit, you could do a PT ratio test, PT burden measurement test, and maybe find out, yeah, that's what's going on. Just like we found on C, you could find something loose or wires broken or something like that. And so then you would find out the same problem where I'm losing money every single day, but I don't have a failure, okay?
Cool. Okay. That was pretty good there.
Yeah.
That was close too, wasn't it?
It was.
Yeah. Okay, so what are we gonna do now?
What you want to do now, Chris?
Read screen.
Read the screen.
He's telling
Oh,
us to read the screen.
can I do a preliminary check before a meter test? No, next screen. Oh, okay. No. Yes, you can. We have some of our family out west. They tend to use a test called an overall test, which is testing over on the primary side. And we had some instances lately where I've been talking to customers. And remember we talked about in the past where if you had a a problem on the, we always say secondary follows primary. So let's say you had a 5S with just two phases, you're dealing with A and C, a delta, and there was a problem where someone had run something backwards on there, something was reversed. Remember in some of the previous webinars, we ended up with like 2 or 3 watts. So we were waiting forever for the pulses, and we realized there was a problem. Well, you could toggle back and forth between the primary and secondary vectors, and if you didn't notice a change on the vectors, then you knew, wait a minute, the problem must be on my primary side. Well, you can run an overall test and actually do the testing ahead of and on the primary side before we CT'd everything down. There's a little bit of math involved because remember you got ratios involved now with these PTs and CTs. So since I'm testing on the primary side now, there's more power involved because I haven't CT'd it down yet because I'm over on the primary side. So what we're going to do is we're going to talk about this overall test, but first we'll talk about how you set it up and a little bit of math involved in it. So, all right, go back here, and I'm going to go to the meter test number 3, and the overall test number 4.
Okay, so right here is where the calculation comes into play. So since we're using 200 to 5 CTs, this is where we need to calculate because we're going to measure primary current here. So we're going to take 200 to 5, divide by 5, which is going to give you 40. And then we're going to calculate the 1.8. So you actually look at the KH of the meter and calculate that in. So that should give you 72. So if you could put 72 in the overall.
So I'm going to change this and I'm going to put 72 now.
Yeah.
72 now,
All
which
right.
Ray is exactly right. You take the 40 to 1, 205 is a 40 to 1, so you take your 40 times the 1.8, you get 72, because we're over on the primary side now, so things haven't been CT'd down, okay? So notice we didn't change any connections or do anything, right? But we changed that, so now we're going to hit next.
The only thing I did was remove the duct bills out of the picture.
Okay, go over that just real quick.
Yeah, I just removed the duct bills out of the picture. So we actually want nothing but the primary probes here to take this measurement. So the duct bills are not in the picture. So we are not wanting to measure our secondary current. We're wanting to measure our primary current only.
That's exactly right. So when we eliminate that, it's going to go directly to the primary.
Cool. Thank you, John. Forgot about that.
No problem.
Watch it be right at 100.
Yeah, wouldn't nail it. These signals do not meet their normal
threshold. Why? Because we have our voltages on that, our currents, right?
That's right.
Okay.
So did everybody see that? Write that down and maybe get it notarized. Ray Gore didn't have the connections on the right place. Right. You might want to get that notarized and frame it maybe. One day it'll be worth something.
We were working on a non-test switch, right? Nothing.
So remember, we had done the burden measurement, so we've moved our voltage connections over there to pick up the voltage there and back to the meter because we did the old V equals IR. So Ray had to move the connections from our CTs where we had the voltages because we wanted to do there and back voltage, there and back current. I can calculate the resistance there and back, which is burden, so that's how we do it. So he's moved them over to here now.
Well, let's try it one more time.
Let's do retro. Yeah.
Well, look at that one. What? Let's see. What we look like here. That's close.
Ooh, that's pretty
Close.
good.
That's pretty good.
pretty good right there.
So meaning that our probes are accurate?
Probes doing good.
Yeah. 99.463. I can move these around a little bit and adjust and get a little bit better reading, of course, but
That's right.
you know, the accuracy of the probes there, that's fairly decent.
So, to think about this for a minute, if you had what we talked about before, if you had a situation where you felt like you looked at what you were seeing on there, I looked at my vectors and everything, and I think maybe the problem's on the primary side of it, you could go ahead and run this test, and you're testing the primary side before it's CT'd or PT'd down where we normally test, okay? So if you want to take a look at that primary side, if you felt like going back to what we said before, secondary follows the primary, if I noticed a problem, I said, well, wait a minute, I'm toggling between my secondary and primary vectors, I'm not seeing any change. I think the problem's on my primary side. You could, while you were there, here's another tool, you could run an overall test and check it on that primary side. And that's when it would show you if you had polarity reversal or some problem on that primary side. Okay?
That's a good point.
Cool.
Very good point.
Cool.
All right. What's next?
I was going to say read the screen.
Yeah, he's pointing at it, didn't he?
Should have never given him the clicker. Okay. How can I quickly see, oh, I like that quickly. How can I quickly see my primary, so you know, Mons, I don't see a lot quickly, but that's all right. How can I quickly see my primary values without probes?
What situation would I be in where maybe I couldn't access my probes?
That's right. Okay, maybe a distance issue. How about a distance issue where they're too far away?
Yeah.
And I couldn't make a connection with my probes.
Let's say, for example, a restaurant. Meters outside, CTs are inside. They're busy. They won't let you in.
Perfect. That's a perfect example. And that does definitely happen. Yeah. You're not coming in here right now. Yeah. Yep, and they're the customers, so you can't say anything.
Yeah.
That's exactly right. So
we want to do
which one you want to do on this?
enable ratios. Is that what we're doing?
Yeah, we're enabling the ratios, right?
Okay. So
Okay.
let me get set up here first.
Sure. So we're going to get our duck bills back in because we had removed them, remember, to do the overall test.
Coming up.
Coming up. All right, so we go here.
Yeah. So you want to go to the power table.
So you can see here, this is F5, one almost never used, but over here. Remember I talked earlier, F4 is where you're toggling between the secondary and the primary. And that is the same button on the vectors as well that you can toggle between primary and secondary. But this enable ratios, if you watch up there at the top, look at my voltage, it's showing 120 volts right now. So what's going to happen when I hit enable ratios, right?
Well, what's going to happen is it's going to calculate for the primary side of things, right? So I'm going to get it like this. And look at there with the 300 volts.
Yep.
And also we're measuring primary current of 103 amps. So, and you can actually see our power as well.
Yeah, the watts.
Yeah.
So we're not used to seeing numbers that big, right?
Yeah.
Because we disable the ratios almost all the time when you're looking at these. I'm always looking at the secondary side. So if I hit it again,
And then it takes it away, goes back to, you're looking
that's
down
what
at
we're
the
used to
secondary
seeing.
side.
That's
Yeah.
what we're used to seeing. But think about that. If you ever showed up, I think Ray's example is just about the best you can come up with. They just won't let you inside right now. You're outside right now. So I can't see anything. I can't do anything. No. You can use this enable ratios right here. So you can see right here. I like that. So
Yeah.
you've got you can show the total watts. See how big our numbers are right here for the total watts we've got right now. Because you consider that's not the non-CT PT numbers. That's the actual real numbers. That's what people get billed on. That's what they get billed on. The stuff we look at in the billing numbers, then they have to put the multipliers back on it through your system or something you got on the computers. This is getting to see. This is what they're going to pay their bill on right here.
Then you can also hit stop right there. You hit F6, and then you can save that. So that's pretty cool.
Nice.
And it prints out the report too.
That's right. That's why they call them the professor folks. So you hit stop, and you can save that if you want to, and put it on a report.
Yeah.
And I haven't really mentioned that much. I'm glad you said that. All these different screens when we're looking at them on here, like we look at our power screen and stuff, I'm glad you said something. We can hit stop and we can save it and put it on the reports.
Yeah.
And I don't know that at least I haven't. They've done a lot of these without me, but you can save these things and put them on all the reports. Man, I would especially encourage that when you see something out of line. If you see something that's not right, definitely stop and then save it. When you hit stop, the save button will pop up. You just hit save and it'll now be on your reports. You can attach all kinds of things on there. If something doesn't look right, save that bad boy and add it to the report.
Yeah.
I'm glad you said that.
Yeah.
All right, cool. So, I guess that's,
What else has got on that?
can I simulate a load in the lab?
Ooh, that's a good one.
That is a good one.
Yeah.
This is the one that Ray was telling me about this morning, because I haven't used this before, but when he said it, it all made sense. Because I was saying, well, why would you want, because remember on the 7 series, have you ever seen us out there at either meter schools or when we're doing training, we got those stands, right? And we power up the stands with our 7 series, and when we're training you, we'll use a 7 series, power up the stand. Then we'll use either, if you're getting trained on a 7 or a 3, we'll have your equipment and we'll actually do the testing on that stand. It's a 9 with some 205 CTs and a test switch, and you've seen it at the schools and seen it at your place if you've got our equipment for the training. And so when you're using all that and we've got that, then it's pretty easy, because I'm using that 7 series. I use the manual load box in it to power up that stand. But I hadn't really thought about using the manual load box because we've got one with 3 now, right? And so Ray was telling me about it. I haven't really used the load box on the 3. I've used the load box on the 7 a lot for powering up those stands and stuff, and for load boost, doing load boost tests in the field. But I'll let Ray tell you about it. You can use this, and it's pretty slick if you want to try out some things. If someone has an issue in the field and can you simulate it? And I'll just
Yeah.
let him take it.
Okay, yeah, so what we can do here is, I'm going to hit previous if you don't care.
Sure.
And I'm going to go to Utilities, hit enter there, and then go to Manual Load Box Control. So what's happened here is we can actually, you know, of course this, we don't have voltage in it, but on the 7 series we'll show you this as well Thursday, that you can actually place checks in these boxes and drive voltage and current. But for now what we've got is we've got current only with this unit. So what you can actually do, which is really neat about this, is you got the phase angles over here that you can actually change and actually test, you know, what you maybe saw on the meter that day you were out there, and guess what? Now there's no load. So, but anyway, that's a neat little feature that you can actually do. And, you know, you can also come down and change as far as frequency as well. So it's a pretty neat little thing. But anyway, what you can do is once you set all your currents up here, then you can hit start, and once you hit start you can actually go hit previous. You can hit previous, and once you go into previous and then go into a meter test and under a customer load test and test the meter with your, you know, with your specs that you've set up for manual load box.
So like you were telling me, it'll capture the changes you made
Yeah.
and apply them to the customer load test.
Yeah.
So you can shift the angle.
You can shift the
You can
angles.
shift the angles, you can
Exactly.
also shift the amplitude, but mainly probably, I remember you telling me it's when guys say, we were out in the field and we saw a 30-degree shift on there,
Exactly.
what's that about? And you say,
Yeah.
well, hold on a minute, you put
You
a
can
30-degree
test it.
shift on it.
Yeah.
Yeah, that's pretty slick.
Yeah, that's pretty slick. And all phases will do that, so that's pretty cool. I use that a lot. I use that a lot.
Well, for all the troubleshooting you're
Yeah.
doing, you're getting a lot of those calls of,
Yeah.
how come my angle shifted? Well, you can actually shift it and simulate exactly what that guy's
Yeah.
looking at in the field.
Especially deltas, by the way. You know, like sometimes when we do a delta test on the ANSI and it shifts that current all the way down to 90 degrees, folks are calling, well, hey, I'm not getting any watts, that's why. So you can actually simulate here of actually what you saw. So that's pretty cool.
That is cool. And I've, like I said, I've used the load box, the manual load box on the 7, but I haven't used it on the 3, and that totally makes sense. And especially for you getting all those
Yeah.
calls of how come I've got this shift,
Phase
well, let me
shifts.
simulate exactly what. It's the same thing when Ray asks you to take a picture, get on FaceTime or something. I want to see exactly what you're looking at, so he can make it exactly what you're looking at by simulating it on here by adjusting that load.
Yeah, I use that a lot.
You know, that's sweet.
Did we talk about the harmonic waveforms?
Yeah, we were going to go to the phantom load setup.
You have to do it there too.
Yeah, you can do it here. I forgot about that. Yeah, the waveforms, you can do the harmonic waveforms here too.
Oh.
I was going to say that, but I didn't want to step ahead of things. But you can actually go up here and actually change there. So you've got phase fire, you've got multi-zero crossing current, and they're pretty neat. So, you know, of course, you're going to look at the sine wave here. So, but you've got phase fire that kind of looks like a sharp spin, and then you've got the multi-zero crossing that's kind of broke up, and, you know, you'll see those to the peaks.
So the sine is normal.
Yeah.
So sine is our normal sine wave that we run. But we have some of the ones that, ANSY's been talking about this for a long time with the harmonics. And they're wanting to load, and now they're causing we thought it was going to affect the field stuff as well, but they did actually pass it so that the manufacturers do have to do a type test on these meters.
Exactly.
So they have to run 8 different funky waveforms through their harmonics, right? So we've already got some of them in here. So if you wanted to simulate harmonics and see how the meter tested, you could actually come inside, put the meter in a socket, and then use the 3 series or the 7, either one. Use the 3 series to actually run a non-sinusoidal, non-beautiful and pretty sine wave, okay? So we can run those through there. So you could actually test your meter if you want to and see how it handles harmonics. Think about it, if you're at a place, a big manufacturing facility that's got tons of conveyor belts, so they got tons of VFDs, variable frequency drives, all this stuff inside there, that's all introducing harmonics on it, okay? So you might say, well, if you start having issues and you're wondering about the billing in a certain place, or a meter and how well it was functioning there with harmonics, you could actually put some harmonics on it with this and test it out and see how it's going to handle it. Because I would have to believe some are better than others. I might be wrong, but anyway, I know we've seen that a long time ago in the past. There was stuff they didn't handle as well. The meters are getting better and better and better now. But you could actually run a test with this and try out the harmonics on there. And you could make it 2 different ways. Chris just showed us the one, but you can actually, on the actual phantom load test, you've seen us set these up before, that one of those last columns over to the right, Ray's going to show you, is the one we don't normally use. That's the one for harmonics, and it's got those different ones in there.
Yeah, so you can actually go over here, and how I got to this point, I kind of moved ahead on you, is I actually went in here under Quick Edit, and I selected the 5 amp quick, and then I'm going to go under F1 Edit, and this is if you've already got your test template set up. And then what I did was I went over here to the Harmonics tab, and then I hit the drop down box, and then there you can see I can make my selection with sine, phase fired, and multi-zero crossing there. So you can do that in the phantom load as well.
That's right. So the default is sine, so it's going to be on sine.
Yes,
but
sir.
if you want to change it to one of the others, you can. The 5 amp quick is just one I had in there while I was running 5 amps. It was just quick. Make sure you guys get that. That was the one that I already had in the machine. So Ray just went in there and edited that one. The 5 amp quick was I was running 5 instead of 2.5, and I had a minimal number of pulses to run it quickly through for either a meter school or one of these, so we weren't waiting for 10, 10, and 10. So I just named it 5 amp quick. And Ray went in that one I'd already set up here that we used on a previous demos, and actually used this with a customer as well to show them. Just setting up 3 sets of tests here for solar and non-solar sites. So Ray just went in there real easy and modified. He went up, and when he hit edit, he could go over and open up the boxes again. So when he hit edit, he went over here and opened up the harmonics box, and it gives us sine, the phase fired, or the one where it keeps crossing 0. So you can put one of those other 2 in there and try a non-harmonic, non-sinusoidal jacked up waveform if you want to, and put it and run it through there. In case it, and I'm thinking maybe if you had a site where you were having issues and you knew there's a lot of harmonics going on inside there, why not take that meter and try it and run a couple harmonics in there and see if maybe that's the issue.
We'll see how well it performs under those conditions.
Yes, sir.
So that's a good feature. I like that. I've used that a lot too.
Yeah, I use it on the 7, of course, but I have to use it as part of stuff, but I hadn't used it for this. That's sweet.
Yeah,
All right, so we can just do this thing.
What's he got on
That's it.
that? Think of anything else? Cool.
We did have a situation the other day, and we can talk about that one right there, I think. But we can talk about this one right here, don't you think?
Yeah.
Yeah, that the boys called in on. We had an actual customer call in, which it was a pretty cool one. And let me see. Get over here, man. And they called in and they were saying if they had 4 conductors running through the CTs, and let's say you had 4 running through A, 4 running through B, but what if they got 2 of them swapped? One of the conductors out of A was running in B, and one of them out of B was running in A. The test kit is looking for a certain phase angle error for it to indicate a problem. So when it sees there's a range there. And when it sees within that range, it says that must be cross phase. When it sees in the other range, which is higher, then it's going to say, okay, that must be polarity reversal. But if it doesn't hit those ranges, you're not going to get the error message. Okay? The range is what, Chris? It's like 100
degrees.
100 to 120 is going to give me cross phase, and then up around probably about the same range on the polarity reversal. So if it doesn't fall within that, it won't tell you it's a cross phase. So what they did was They actually sat there and tested each of them. All they did was they just wrapped each conductor and were able to trace the conductors through there and find out that that problem was that one conductor was running through A1, and they weren't labeled, by the way, so there wasn't any labeling on them. So when they tracked it down, and sometimes you got to do that, they just tracked each individual cable in there, and they just wanted to see what phase it was attached to. When they did that, they realized they had one that was in the wrong one, but they were colored the same way. You just looked at it, it wasn't labeled any different, so you wouldn't have just visually looked at it. But they realized that the numbers were off just a little bit and had been for a while. And we keep saying that over and over. It's these and this. So you notice a little problem. Well, remember, almost every time it's costing us money. It seems like very few of these problems work in our favor. Most of the time it's costing us money. Okay? So any of these issues, we need to dig down and find what it is. And those guys used a great way of doing it. So they tested each one of the phases on their primary versus secondary, and they found it. So, so I thought that was pretty sweet the way they did it. And they could have also looped them and done an overall test. It would have shown, because one of them would have went off.
That's a good point.
Yeah, they could have done an overall test and found that.
So
that
one of the
would
things we showed today, they could have used on that, and they could have found that. Okay? So, well, once again, the professor and I just really appreciate you guys giving us your time today. Remember, coming up Thursday is going to be advanced stuff with the 7 series, things you haven't seen before. If you've got something you'd like to see, send it in, and Jared will let us know, and we'll add it in there. Some of the stuff you saw today was from customer input, and we love that, because then we can give examples of customers out there. So just be safe out there. We'll see you guys Thursday. God bless, and be careful.
Peace.